Hello, this is Karen, and in this video we are going to discuss what is happening or attempting to be happening in this little piece of pseudocode. If we take a look at the pseudocode, it is doing what we call a counting routine. So if a number is 1, it adds 1 to count. If the number is 2, it adds 2 to count. If the number is 3, it adds 3 to count, and etc. This is a pretty typical simulation of rolling a die, and so we are going to take a look at what this might be in code. In CodeBoard, I have set up a Java project. Because I'm dealing with random numbers, I'm going to use this import java util.random. We are going to demonstrate random numbers and counting variables. Remember that a counting variable will increment or decrement by a set amount. An accumulating variable will increment or decrement by different amounts. Typically we have them incrementing, but they could go down as well. Think of like a countdown for a liftoff. So in this example, I have set up a constant for my maximum. I have 6 variables that are going to do counting for us. I created a random number variable, assigned it to 0 to start. When I use the random library in Java, I need to create what's called a random object to work with. So that is random rand equals new random. I used a for loop, which you may or may not be familiar with, and this is the piece of code that generates our random number. So when I generate my random number, I use rand, which is my rand object from line 21, and I use the built-in command called .nextInt. My max is 6, but that particular routine will generate a random number from 0 through 5. So I have to adjust that by adding 1 to make my numbers go 1 to 6 because I'm simulating rolling a die. If you were doing pseudocode for it, off to the right-hand side here, this is what our pseudocode would look like. Random number is assigned random parens limit, and actually the limit here would be max if we were using this max value. And in that case with pseudocode, we would assume the value is generating from 1 to 6. It's a little bit different on different systems, and so you have to play around with that. Next, I'm going to print out my random numbers, and then here's the piece of code that's similar to what we had in our course. So if the random number is 1, we're going to add 1 to the count variable for 1, and etc. If I compile and then execute this code, you're going to see that it tallies how many 1s, how many 2s, how many 3s, etc. were rolled when I rolled the dice 100 times. These numbers should be fairly consistent because I have a 6-sided die, and theoretically it is a fair die, and so these numbers should be distributed fairly evenly. This has shown you then how we can use a program to count occurrences of the number of times a die has rolled a certain value, and so these are examples of counting variables because they increment by 1. The rest of the video is going to show some shortcuts and some tricks with Java, so you can keep listening if you want, but the main objective of showing you counting variables is accomplished. The first little shortcut I'm going to show you is that there is a way to add 1 or increment by 1 in Java. Instead of using count equals count plus 1, there is a shortcut, and that is using what we call the plus plus operator. And so I can change all of my count whatever plus 1s to count plus plus, and I've already changed the rest. We can compile, and we can run, and we can produce the same results. So that works to add 1 in Java as a shortcut. The last thing I'm going to do is to show you how you could do the exact same thing using the case statement in Java. I deleted all of my if-else-if statements, and I'm going to replace it with a switch case structure. So in Java, we have seen this with our pseudocode, but let's see how it works in real life here. When I generate a random number from 1 through 6 here, it's going to come in here as a value of 1 through 6, and the case statement is going to process as it's an if-else-if statement. If it's 1, it's going to increment count 1. If it's 2, it will increment count 2, and etc. With a case statement, we do have a break statement after every if case situation, because that's kind of like closing off the last curly brace, and the flow of control then breaks, and none of these other statements then get executed or looked at. So it increases and improves efficiency. The same efficiency happens with if-else-ifs, because the rest of the else-ifs are never looked at if the first one is true. If I compile and execute or run this code, we should have similar results to what we had before. The numbers should be fairly evenly distributed. And so that shows you how you can do an if-else-if situation with a case statement in Java. One note is that you need to have what we call either an integer here or a character. In Java, you cannot use strings on your case statements.